All right, hi everyone. These are the notes from GN3, GN being your graphing notebook. So this should be the paste in page that looks familiar. We're going to talk a little bit about observations and inferences. If you are absent, make sure you jot down the blue text for your definitions of observation and inferences. So when you're observing something, you are using your five senses: taste, smell, what you hear, what you see, what you feel, to record information. We're not making assumptions. We are just recording what we see most frequently for this class. We have two types of observations. One is quantitative observations. Our memory tool is, if you are asking how many in Spanish, you would say cuantos or cuantas. Quant relating to a quantity. So a quantitative observation involves numbers. There are 3 people. There are 2 wheels. There are 15 pencils. There are 36 students. He jumped 14 inches. Okay, using numbers, sometimes with units. Qualitative observations do not include numbers. So it's just what you see, describing the quality of an object. Our memory tool is qualer. So if you add OR to the root word QUAL and say it fast, it kind of sounds like color. So color could be an example of a qualitative observation. The highlighter is yellow. The surface is smooth. The surface is bumpy. The basketball bounced vertically. The basketball bounced to the left. Qualitative versus quantitative observations. Based on what you see, you can make an educated guess or conclusion. So for the picture on the left, we might infer that these 3 people are at a concert because we see lights, but we don't know that for sure. We may infer that it's Beyonce and Jay-Z and their daughter Blue Ivy, but we don't know that for sure. Could be a wax figurine. We could assume that they are a family. We could assume that they are a happy family, but we don't know for sure. Educated guesses or conclusions based on observation may or may not be true. Same thing for the bottom picture. We might assume that it's from The Martian, but we don't know for sure. Okay, let's move on. And talk about accuracy and precision. So this you'll record on the bottom half of GN3 or on the back. You do not have a paste-in page, so do your best to draw these 2 dartboards. We have dartboard A and dartboard B. So go ahead and fill in the definitions of accuracy and precision. Accurate meaning correct or close to the real, close to the expected value. We could add in here, or true value. Precise is repeating, or consistent, or repeatable. So in your presentations, I'm seeing a lot of teams use accurate results without explaining why your results would be accurate versus precise. So let's use dartboards for an example. And we have, so the goal of darts is to hit the bullseye right in the center every time. So ideally you would be both accurate, close to the expected value, in this case the bullseye, and you would be precise, you would be consistent. Ideally you would have all 4 darts in the very center of this bullseye here. So let's analyze the results of these 2 dart arrangements. So on the left, we have results that are close to bullseye, but they are all kind of scattered. So we can say not consistent, not close together. And then we have another arrangement that is kind of the opposite. So these darts are far from the bullseye, but they are consistent, close together. So let's try to identify which dart arrangement is accurate, which is precise, or if one is both. Okay, so in this case, let's look at accuracy first. These darts are relatively close to the bullseye because they're in the first ring. So we can say they are close to the real, expected, or true value. This would make these darts accurate, or these shots accurate. Here we are far from the bullseye, so not accurate. Okay, and then let's look at precision. Are these darts close together? Yes, they are, so they are precise. These are not precise. They are not close together. Okay, so it is possible to be accurate without being precise, and to be precise without being accurate. Sometimes you can be accurate and precise, which is the goal in any experiment. So let's look at a different example. This is a player who throws free throws that always makes the basket this exact same way. In this case, the style is granny shot. In this case, the goal would be making the basket. That's the goal of basketball. So if this player makes a basket every time, he would be accurate. He would be an accurate shooter. If he uses the same exact technique and the ball hits the same part of the rim or the backboard every time, then he would also be consistent and the shots would be both accurate and precise. So we can highlight or bold this. Let's see. Accurate and precise. Okay. Consistent, makes basket every time. Let's look at another example. This time, same sport, little more injury involved. Doesn't make many baskets. So we right away know that he is not accurate. He is not close to the expected value. The expected value would be making the basket, but always strikes the exact same portion of the backboard. So he is consistent, he is precise, but he is not accurate. So this would be the appropriate answer for this example. Okay, so does not make basket, but he is consistent. Okay, let's look at another example that's a little bit more specific to your experiment. If you measure the mass of a 50-gram marble, so this is our expected value. Our expected value is 50 grams. That's how it was made. We should see 50 grams pop up on our scale. However, our scale reads these values: 47.5, 47.6, 47.5, and 47.7 grams. Okay, this is not close to 50. 47 for this class would be too far from 50 grams, so it is not an accurate reading. However, all of the values are very close together, about 1/10 apart for most of them. So they are consistent, but they are not accurate. We can again highlight this example. Precise, not accurate. Close together, far from 50.0 grams. Another data table. Our expected value is 0.5 seconds. So in our 4 trials, we get 1.21, 1.25, 1.27, 1.24. 1.2 something is very far from 0.5. So again, we are not accurate. We are far from the true value. However, all of the times that we collect are very close together, 1.2 something. So best answer here would again be precise, but not accurate. Close together, far from 0.5 seconds. Okay, last example. We have an expected value of acceleration due to gravity on Earth. This should be constant anywhere on Earth. And our trials, where we are testing the acceleration due to gravity, are 9.81, 9.78, 9.82, 9.77. For this class, these values are accurate. They are very close to 9.8. For this class, these are also very precise results, meaning they are all very close together. They are all within 0.03-ish of each other. So this would be an excellent experiment. We get something close to acceleration due to gravity, and they are all very close together. So accurate and precise would be the best arrangement of our values. Close together and close to 9.8 meters per second squared. Okay, so for your experiments that you designed, you're not really testing to prove the speed of light or to prove a known value like gravity. You are guessing, okay? So you have a hypothesis. You may expect a fidget spinner to spin for 28 seconds, but you don't really know. There's no research. You may research the mass of a basketball that you are using, so that might be an expected value. And then your experimental value would be whatever the scale reads when you measure the mass. So for most of you, you're not really looking at accuracy of your results. You're looking to analyze how precise your results are. Precise being how close your numbers are together. In this previous case, if we had these values way far off from our expected value, we might have a source of error that has to do with the stopwatch. Okay, if we're more than a second off, either human reaction time or the stopwatch itself was inaccurate. Precision is what we're going for, so you want to be consistent. That's why we have control variables, so your results are very close to each other. Please reply with questions or bring your questions to office hours. Hope this was helpful. Goodbye.